So this is the Waves Homework Booklet question 2. We've got a diagram here representing a wave travelling in that direction. First thing we ask to do is to calculate the wavelength of the wave. Now I've got a distance on the graph from x to y, and that's 0.5 of a metre, which is great, except it's not, because a wavelength is from x to this point I've marked here, z, not all the way on to y. If I look at that carefully, I've got a quarter wavelength from the peak to the equilibrium, another down to the trough, 2, 3, 4 quarter wavelengths, 5 quarter wavelengths. So I've got the 5 quarter wavelengths are this 0.5 of a metre. So I've got a quarter, each quarter wavelength is 0.1 of a metre, so a whole wavelength is 0.4 of a metre. Part 2, very straightforward, using that wavelength that we've calculated up here and the frequency that we've been given, c equals f lambda, we can calculate the speed of the waves, 8.8 metres per second. Next we've got to state the phase difference between points x and y. We come back up and look at the diagram. It's one useful way of doing it is to look at x and realise that is moving in phase with z. They're moving they're a whole wavelength apart, they'll be moving in phase. I can then think about the phase difference between z and y, which is the same as the phase difference between x and z. That's a quarter of a wavelength further on, so it's a quarter of a cycle, which is pi by 2 radians. You could, however, think that it's 5 quarter wavelengths on, so it's 5 pi divided by 2 radians. Either one of that will do. And if trying to get an intuitive feel for it doesn't work for you, you've always got the equation 2 pi x upon lambda. So in this case, 2 pi times 0.5 over 0.4 leaves me at a half pi or 5.5 pi radians. Those two are equivalent because anything which 2 pi is the same as naught when we're talking about phase difference, because that is what 2 pi is, one cycle. Finally then, describe how the displacement of point y on the string varies in the next half period. So I'm looking at point y here. The wave's travelling left to right. The next thing that will go arrive is the peak, which is currently at z, and then it'll return to the equilibrium position. That's actually a complete half cycle. So that's all we need to think about. It would in fact be a trough after that, and back to the equilibrium, then another peak. So look at what's coming, look at what's approaching y in the direction of travel. Remember, it's a transverse wave, so all that y can do is move up and down, so the movement must be straight up or down. So go and have a look at the answer. We'll have a maximum positive position after a quarter cycle, and it's linking together the position and the when it'll be there, and then it'll return to equilibrium position at the end of that half cycle. So that was the Waves Homework Booklet question 2.